The Rangeland Analysis Platform's Vegetation Cover dataset is a powerful view at the past 37 years of vegetation cover and how it's changed through time across the entire western US. But the question remains when looking at these data on RAP, where does this data come from? What underpins the models that produce these maps? Having a basic understanding and intuition about how these maps are created can help you in interpreting the outputs that you see in the RAP web application. When you go to rangelands.app and open up the vegetation cover dataset, you'll see 5 datasets: perennial forbin grass, annual forbin grass, shrub, tree, and bare ground. But the question we seek to answer with this video is, where do those datasets come from? Well, for the vegetation cover dataset, we use an observation model. This is as opposed to a process-based model, which we use for the herbaceous biomass dataset, and we'll talk about in a short video coming up. An observation-based model. You may be asking, what types of observations are we talking about? Well, in the case of the vegetation cover dataset, we're talking about 2 types of observations. The first is satellite data, and the second is field vegetation data. And these are both tied together by cloud computing. Okay, let's look at both of these datasets and the cloud computing in slightly more detail. We'll start off at a high level, looking at the satellite data. Our satellite data come from the Landsat program, which is a joint program between the U.S. Geological Survey and NASA, and has been surveying the Earth for over 36 years. It covers the globe every 16 days, and you can see what these coverages look like on day 1 and day 15 of any cycle. It's been doing this for 36 years, and that's a lot of images. In fact, in September, they surpassed 9 million images in the Landsat archive. Landsat is considered a moderately high spatial resolution satellite. It's 30-meter spatial resolution, which means that each pixel in the image equates to 30 by 30 meters on the ground, which is roughly the size of a baseball diamond. This is a powerful dataset, but at the same time, it doesn't tell us about the vegetation types that are on the ground. And for that, we need field data. Our field data come from 2 sources: the Bureau of Land Management's Assessment, Inventory, and Monitoring dataset, and the Natural Resources Conservation Service Natural Resources Inventory dataset. Collectively, these 2 datasets go back to 2004, and in that time, they've collected 60,000 plots that can tell us about the types of vegetation that are on the ground in those locations. 60,000 plots and 9 million images is a lot of data to process, and for that, we rely on our partners at Google, who produce the Google Earth Engine, which helps us to process all of that data. So now that we have some understanding of the types of data going into the vegetation cover model, how do we produce the model at a high level? Well, from the field data, we take observations of our vegetation classes of interest for each plot in the dataset. And then for our satellite data, we take images from 6 different times of the year that can relate to different phenological patterns: green up and senescence, all of these different periods. For each of those images, Landsat measures 7 different types of reflectance as well. And finally, we throw in a spatial location variable because we know how much rangelands vary across the western US. We take all of this data and give it to a machine learning model. The machine learning model finds patterns between the vegetation classes on the ground and the satellite data from the Landsat program. Based on the relationships between those 2 datasets, the machine learning algorithm produces a model that makes explicit those relationships between the remote sensing satellite data and the field vegetation characteristics we're ultimately interested in. Then, we can take that model and apply it to all of the Landsat data, going back to 1984, even before we had field data. And using those relationships, we produce maps of the vegetation characteristics we're interested in: annual herbaceous, perennial herbaceous, shrubs, trees, and bare ground. And we don't just do this for one point in time. We produce it for every year going back to 1984. Thank you for joining me for this short video on the vegetation cover dataset in RAP. If you have any questions or comments, please leave them in the comments below, and I'll see you next time.